Hey guys, Brady Hansen here with Safeguard Equipment, and I wanted to talk today about the current sensitivity and the current detection of the Safeguard compass. Now, this technology is amazing because it allows us to do things like this. When I've got an energized object carrying current, like I do behind this drywall right now, I can actually perceive it with my Safeguard compass unit. That's profoundly cool. But at the same time, we also want to make sure that our customers know some of the limitations. Now, the way we're able to read current flow on a conductor is we use the magnetic field. There is a right-hand rule with current flow in a magnetic field, and the right-hand rule says this: if current is flowing in the direction of my thumb, then at a 90-degree angle to that current flow will be a magnetic field that comes out of that conductor. So here is the challenge that can present. If I've got a conductor and the current is flowing this way and I get that current flow, and I've got another conductor and the current's flowing this way and I get this magnetic field, those two magnetic fields can actually start to cancel themselves out. So when it comes to the detection in the Safeguard compass, detection really depends upon the amount of current flowing in a conductor, the polarity of those currents, the distance away from the current carrying conductor, and also cancellation. So today we've got a grounding test unit that produces an alternating current, and we're going to pass some current through this medium voltage underground cable. Now this is an alternating current. This is low voltage testing, very, very low voltage, and that's why we like using this particular piece of test equipment. So Kevin, our accountant here and CFO of Safeguard Equipment, is going to help me as we do this, but again, there's not a lot of voltages. There are, however, some currents though. So Kevin, how many amps do you got right now?
Just 2.
Okay, so we're looking at about 2 amps flowing through this primary underground cable. We got 2 amps of current flowing down the primary conductor, 2 amps flowing through this feed-through bushing, and then 2 amps flowing back through this personal protective ground. So if I get my compass unit here, you can see I've got current detection in this part of our circuit because those 2 conductors aren't canceling each other out. Now, let's take a look at what happens mid-span with a medium voltage underground cable. I've got a primary that's carrying current that's going that way, and a neutral carrying current going this way. I get cancellation. For this reason, we absolutely insist that you never get complacent. No matter how good of technology you might be wearing and utilizing, complacency kills. That's been true from the first amp that was ever produced. When it came to a cable like this, truly determining whether or not it was energized or de-energized would only be determined by following well-established safe work practices and observing all relevant OSHA rules. But, yep, watch this. Okay, Kevin, go ahead and turn it on up to about 25.
Okay, got it there.
Okay, now let's take a look and see if we start to read this current. So you can see here at the sensitivity range, and I'm in the high sensitivity range right now, it's picking up that level of current. So watch what happens as I move the compass away. It goes down. As I bring the compass closer, it goes up. And then Kevin, go ahead and start to turn that down, and let's watch as Kevin turns down the current, the compass unit.
18, 15, 10,
Okay, so we're there.
5.
So when it comes to discerning whether or not a cable is energized, we would never want to completely rely upon the Safeguard compass unit for that purpose. Now, a lot of times with multiple phases, we end up seeing the vectoral sum of currents flowing in the neutral, which is why this compass unit, as you've seen in other videos, is so good at detecting underground cables through soil, through conduits, etc. This single phase underground scenario is one of the most challenging current-wise. So again, all of us here at Safeguard Equipment absolutely insist that you not get complacent. You use all well-established safe work practices and observe all relevant OSHA requirements. And for those situations where having the world's best personal voltage and current detection device can help you, we urge you to consider buying the Safeguard Compass. Thank you.